Well, in this one, we're going to try to find out where the vertical asymptotes are. Well, we know from power functions that vertical asymptotes happen when the bottom is equal to 0. So if I'm looking for vertical asymptotes, I'm going to try to set the bottom equal to 0. And that's just going to be, again, because the bottoms are always polynomials, right? We're always going to do that by trying to factor. And I should then get x equals 2 is an asymptote, x equals minus 2 is an asymptote. We're going to see at the moment that that's actually not quite enough to help us graph, because if I go to x equals minus 2, that's this line. And if I go to x equals 2, that's this line. And sure enough, we're going to get asymptotes, but it's hard to tell what's going to happen, because asymptotes can happen all sorts of ways. For example, an asymptote could look like that. Yes, or an asymptote could look like this. Yes, or an asymptote could look like this. Come on, you off. Boy. Okay, never going to use that marker again. Right, could look like this. Right, so what we're going to do tomorrow is try to figure out if we're guaranteed that there's an asymptote there, what color thing are we going to get? But finding the asymptotes usually isn't that bad, except the same kind of quirky thing that happened with zeros. So let's just change this a little bit. I still want the bottom to be x squared minus 4. Let's see here. What do I want for the top? How about x squared minus 4x? Oh, heck with it. How about plus 4? We'll do that. Now normally if we're looking for asymptotes, we would set the bottom equal to 0. But just to show you what weird kind of thing can happen, I'm going to set the top equal to, well, I'm going to factor the top, I'm going to factor the bottom. The top factors as x minus 2 quantity squared. The bottom factors as x minus 2 times x plus 2. Now normally what happens is we get an asymptote because this function really can't be defined when x equals 2. But if we were allowed to cancel, we would cancel this little thing here and this little thing here, and we could see that somehow, some way, we might actually be able to define a y value when x equals 2. What that means here is this one doesn't have an asymptote at x equals 2, it has a hole. We'll try to use Desmos tomorrow when we're actually looking at the shapes of things and what kinds of asymptotes we have. But meanwhile, we find zeros by setting the top equal to 0. We find asymptotes by setting the bottom equal to 0. And we have to watch out for those weird quirky things where the top and bottom share a factor and the graph actually has a hole there.